So what we're going to do is to plot the owners and the non-owners, okay, with income and lot size as the two axes. Okay, so let's look at income and lot size for just the owners. And then insert a scatter plot, okay, like that. Okay, and then so that's your first data series, and we'll call the data series owners. So these are the points for owners. Okay, and then we'll add. Did I do that right? 18. Right. Okay. And then we add non-owners. Okay. So now the x-axis for non-owners is income, that part. Y-axis is this part. Okay. So now we have owners and non-owners. So that should be changed to owners. So owner and non-owner. Okay. So now let's format these to go from 30 and number format 0. Okay. Alright, that one again, let's format it to go from 10 to 25, and number format is 0. Okay, so now we have chart separated by owner and non-owner. So this will be like income versus lot size. So this will be income $1,000 and lot size 1,000. Okay. So now we have a chart of what all the owners and non-owners characteristics in terms of the two predictor variables, income and lot size. Right? So there is a good separation here between the two. Now suppose we have a new record coming in, 60 and 20 for income and lot size. Okay. So let's go ahead and insert that point into this graph. Okay. So it's design, select data. So now we're going to add one more. Okay. The x value is 60, y value is 20. Okay. We'll call that a new record. Okay, so now we have the new record right there. We can format that. Alright, so you go to marker, and then you can change the color to green, and you can increase the size, say 5 or something. Alright, color didn't change, how come? Marker, solid color, oh, this one. Okay. So now we have the new observation. Alright. Now if you use k equal to 1, nearest neighbor 1, the first nearest neighbor, and that's it. You're going to use that as your classification. So what will you classify as? Okay, let's add the legend so we'll know what we're talking about. All right. So the nearest neighbor is an owner, so you will classify this as an owner. Right? So we are now talking about in 2 dimensions the straight distance. What is the distance between the new record and the nearest one? So if you're using 2 nearest ones, then I don't know whether that one is closer or this one is closer. It looks like these two. 3 nearest would be, I guess, like that. Okay, and then so on and on. Alright. So let's do this. Let's go ahead and compute the distance between this new record and each of the trained records that we have. And how do you compute the distance between 2 points in 2 dimensions? What's the formula for that? Square root of the difference in the x coordinates squared plus the square of the difference in the y coordinates. Right? Sure. It is this. Alright, so in 2 dimension it will be like that, square root of, okay, so here are the first, okay, so the new household is income 60,000, lot size 20,000, right? So that will be x equal to 60, y equal to 20. So the distance for the first observation will be 60 minus 60 squared plus 20 minus 18.4 squared, so that gives you the distance. The distance between the new observation, the second training set observation, so 60 minus 85.5 squared plus 20 minus 16.8 squared. Again, that's under square root. You have to take the square root of that. So that way you can compute the distance of each of the training observation to the new observation. So let's go ahead and do that. And there is a simple formula for this in Excel. All right. And that would be so that will be square root of, there is a function called sum, okay, sum, okay, so here sum x minus, so x m y, so it is x minus y, 2 stands for square. So it sums the square of the difference between 2 corresponding range of arrays. So sum x minus y squared, so that would be like that, right? And up that, absolute reference that, and then that. Okay, so you take the first number from each range, subtract square, and then the second pair, subtract square, and add them up. So that's that part, and then you take a square root of that, so that will give you the distance. Okay, so all right. Now the ownership, I'm going to just copy paste the ownership here. Well, let's do this. Okay, let's do ownership like that. So first observation, the distance. Second observation, the distance. Third observation, the distance. So that's what we have here. Right? Now what we need to do is to sort this by distance. Okay. So I'm going to copy paste this as values. Okay. So come here and paste values. Should be that. Okay. Then you sort this by distance smallest to largest. Alright, so now we have the nearest closest ones and what the ownership information. Okay. Now we need to find how many events are there in each neighbor. So if you're going to use k equal to 1, it is just that. K equal to 2 is that. K equal to 3, k equal to 4, k equal to 5, and so on. Okay. So how many events are there in each of them? So we can do a count if. Alright. So count if. Alright. First one should be absolute referenced. So count if. So that's the range. And the criteria is owner. Now if I go, it'll tell you exactly how many owners you have as you go down k. Okay. If k equal to 1, you have one event. K equal to 2, 2. K equal to 3, you have only 2 owners. K equal to 4, 3. And then 3, 3, 3, 3. So the pole here, pole is the proportion. How many owners are there as you go down k? So the number of events divided by how many neighbors you consider. So event here is owner, and suppose if you have a cutoff of 50%, then your prediction is if the pole percentage is greater than or equal to the cutoff, okay, then it'll be owner. Otherwise, it'll be non-owner. So up to 50%. So now k equal to, if you use k equal to 1, you will classify this as owner. K equal to 2, up to 6, you will classify as owner. Beyond that, you will classify as non-owner because the pole falls below the threshold.